Hey tech enthusiasts, welcome back to ChatGPT Insights. The AI world is moving at warp speed, and we've got the absolute must-know updates that drop this week. Get ready for a deep dive into game-changing AI advancements that you won't want to miss. We're talking about the future of coding, the surprising sustainability of AI data centers, a revolutionary way to run AI models locally, and a peek into how programming's biggest minds are leveraging these tools. Stick around because this is shaping up to be an epic episode. First up, the feature that's redefining how we create software, GPT-5's mind-blowing vibe coding capabilities. Then, we're diving into the data center efficiency that's defying expectations. After that, we'll show you the ultimate setup for running powerful AI models right on your own machine. And finally, we're uncovering the secret AI workflow of a tech legend. Don't go anywhere. The vibe coding revolution, GPT-5 Unleashed. Get ready to code like never before. The latest iteration from OpenAI, GPT-5, has officially landed, and it's not just an upgrade, it's a paradigm shift in how we interact with and build software. While GPT-5 promises a suite of improvements, including enhanced speed, utility, and a sleeker user interface with more customization and an improved voice mode, one feature is stealing the spotlight: its groundbreaking vibe coding ability. This isn't just a buzzword, it's the democratization of software creation. Vibe coding, in essence, is the art of building applications, software, or tools using natural language prompts, bypassing the need for traditional coding expertise. You describe what you want, and the AI handles the intricate process of writing the code. OpenAI's GPT-5 is poised to transform this nascent field from a novelty into a mainstream development methodology. The company claims GPT-5 acts as a personal coder, capable of generating custom, interactive applications from simple, natural language descriptions in mere minutes. This capability is a dream come true for aspiring developers and innovators alike, offering a pathway to bring ideas to life without the steep learning curve of programming languages. During the GPT-5 launch event, demonstrations showcased this power vividly. An OpenAI team member crafted a prompt for a French language learning app. This wasn't a simple text-based tool, it included a game reminiscent of Snake, where players interact with French vocabulary and integrated progress tracking and quizzes. GPT-5 reportedly generated hundreds of lines of code in minutes, delivering an application precisely matching the detailed prompt. OpenAI further explained that GPT-5 excels at agentic coding, meaning it can undertake complex coding tasks autonomously for extended periods without constant user supervision. To put these claims to the test, our own tech editor at ChatGPT Insights tasked GPT-5 with a complex visualization project, recreating the sinking of the Titanic. The prompt requested a detailed visualization showing the ship's interior, the timeline of events, the role of waterproof compartments, and interactive elements allowing users to pause and click for information. The results were a stark contrast to GPT-4o, which struggled with the initial debugging and produced minimal, barely interactive visualizations. GPT-5, however, tackled the assignment with remarkable efficiency, generating a realistic, interactive visualization that accurately depicted the ship's progressive flooding and allowed for timeline navigation. While minor refinements in prompt engineering and graphic layering might be needed, this represents a monumental leap for vibe coding. While GPT-5 isn't flawless, expect to refine prompts and debug occasional errors, much like communicating with any intelligent entity. Its performance significantly surpasses its predecessor. Initial comparisons suggest GPT-5 may even rival or surpass competitors like Anthropic's Claude in coding prowess, though independent benchmarks will be crucial for confirmation. This evolution signals a future where natural language becomes the primary coding language, potentially eliminating the need to learn traditional programming syntax. The way we create software is fundamentally changing, and GPT-5 is at the forefront of this revolution. But what about the power behind these AI models and the infrastructure that supports them? Does it come at an environmental cost? Next, we're exploring the surprising efficiency found within AI data centers. AI's energy footprint: data centers are more efficient than you think. In the whirlwind of AI advancements, from the capabilities of GPT-5 to the open sourcing of Grok, a persistent concern has been the technology's immense energy consumption. Studies have painted a stark picture, suggesting AI models could rival the power usage of millions of homes daily, alongside significant water demands for cooling. However, a recent report offers a more nuanced and encouraging perspective on the environmental impact of AI infrastructure. A collaborative survey by the UK Environment Agency and Tech UK, examining 73 data centers across England, has revealed surprising efficiencies. The findings indicate that the commonly held belief about AI data centers being voracious consumers of water might be overstated. The report highlights that 51% of surveyed data centers utilize waterless cooling systems, and a significant 64% consume less than 10,000 cubic meters of water annually, a figure comparable to, or even less than, an average recreational center. Furthermore, 89% of these data centers actively monitor their water usage, demonstrating a growing commitment to climate-conscious operations. Richard Thompson, Deputy Director for Water Resources at the UK Environment Agency, expressed optimism about these findings, noting the sector's adoption of diverse cooling technologies and increasing water consciousness. He emphasized the critical need for technological advancements to align with environmental protection, ensuring sustainability is central to the sector's ethos, and that water usage adheres to evolving standards. Despite these positive trends in water efficiency, the energy demands of AI remain a significant challenge. While the situation has improved since 2023, the escalating need for AI processing power continues to strain global energy resources. Pinpointing exact energy figures is difficult, as many AI companies remain tight-lipped about their usage data. However, estimates suggest a single AI query can consume substantial energy. Sam Altman of OpenAI, for instance, indicated that an average query uses approximately 0.34 watt-hours, equivalent to an LED light bulb's consumption over 2 minutes. Google's figures for Gemini suggest a lower average of 0.1 watt-hours per query, though the company cautions this may underestimate the total footprint. Early estimates for platforms like Grok suggest a higher usage, potentially between 1 to 2 watt-hours per query. Encouragingly, the energy requirements are decreasing as the technology matures. Google reported a dramatic reduction in the energy and carbon footprint for its Gemini text prompts, achieving 33x and 44x decreases respectively, while simultaneously improving response quality. Google is also pursuing a comprehensive sustainability strategy, including optimizing usage during peak hours, maximizing performance through techniques like speculative decoding, and reducing overall workload. Even with these improvements, Google's total energy consumption has doubled in the last 4 years, reflecting the rapid expansion of AI services. With a significant portion of the population now regularly using AI, public concern over its energy costs is rising. This underscores the responsibility of major AI players like OpenAI and Google to develop and implement solutions that mitigate AI's environmental impact. While some inefficiency is expected with cutting-edge technology, the cumulative effect of data centers on local communities and the planet is undeniable. Just as early computers evolved from room-sized machines to pocket-sized devices, AI technology must similarly scale down its resource demands. Given the current climate crisis, a more ethical and considerate approach to AI development and deployment is not just beneficial, but essential. The revelation of improved water efficiency in some data centers is a welcome development, but it represents only a small step in the much larger journey towards sustainable AI. Running these powerful AI models often means setting up complex infrastructure, but what if there was a simpler, more optimized way? Next, we're diving into the best method for running powerful AI models locally. Effortless local AI. Master GPT-OSS with Llama.cpp and Open WebUI. For enthusiasts looking to harness the power of large language models, LLMs, without relying on cloud services, running them locally offers unparalleled privacy and control. However, the setup process for tools like Llama.cpp, a a popular backend for running LLMs, can often be complex, requiring multiple tools and lacking a user-friendly interface out of the box. This guide presents the most streamlined and optimized method to set up and run the GPT-OSS 20B model locally, combining the efficiency of Llama.cpp with the intuitive interface of Open WebUI. This tutorial focuses on a simplified, Python-centric approach. The first step involves ensuring you have the UV command line tool installed, which helps manage Python environments and dependencies efficiently. If UV is not installed, instructions are provided to download it via their official guide. Once UV is ready, the process involves installing a specific Python version, 3.12 in this case, creating a dedicated project directory, and setting up a virtual environment to manage project dependencies cleanly. This ensures a reproducible and isolated setup. The core of the setup involves installing the necessary Python packages. This includes updating pip to its latest version, followed by installing the Llama.cpp Python server package. Crucially, this version is precompiled with CUDA support, ensuring maximum performance for users with NVIDIA GPUs. Additionally, the tutorial guides users through installing Open WebUI and Hugging Face Hub, essential components for the user interface and model management, respectively. The commands provided are straightforward, minimizing the need for complex compilation or build processes. Following the package installations, the next critical step is acquiring the GPT-OSS 20B model. The guide recommends downloading a quantized version, specifically MXFP4, from Hugging Face. Quantized models are optimized to reduce memory footprint while retaining significant performance, making them ideal for local execution on consumer hardware. A simple terminal command facilitates the download. Once the model is downloaded, the process shifts to serving it via the Llama.cpp Python server. The tutorial details the command to run the server, explaining each flag. Model to specify the model path, NCTX for context window size, NGPU layers to leverage GPU acceleration, and host and port for network accessibility. Successful execution is confirmed by specific log outputs, and a simple curl command can verify that the model is loaded and accessible. The final integration involves connecting the server to Open WebUI for a seamless ChatGPT-like user experience. As Open WebUI is already installed, the next step is to launch its server. This requires opening a new terminal window while keeping the Llama.cpp server running. The launch command starts the WebUI server, typically accessible at http://127.0.0.1.9000. The initial launch prompts the creation of an administrator account, which is vital for saving configurations and settings. By default, Open WebUI is configured to work with a Llama. Since the model is being served via Llama.cpp, a crucial configuration adjustment is needed within the WebUI interface. This involves navigating to the settings, disabling the Llama server, and then manually adding the Llama.cpp server details, including its API endpoint URL. This ensures Open WebUI communicates correctly with the locally running model. The author emphasizes the simplicity and efficiency of this Python-based approach, contrasting it with previous methods that involved cumbersome repository cloning, CMake builds, and extensive debugging. This method, utilizing the Llama.cpp Python server and Open WebUI, offers a ready-to-go, private, and optimized local LLM environment with minimal hassle. It successfully streamlines the setup process, making powerful local AI accessible to a wider audience. Now that we've covered how to run AI models efficiently, let's look at how the pros are integrating these tools into their workflows. Next, we explore the sophisticated AI-assisted programming strategies of a tech luminary. Andrej Karpathy's AI programming stack, Cursor, Claude, and GPT-5 as the ultimate toolkit. In the rapidly evolving landscape of AI-assisted development, Andrej Karpathy, a renowned AI expert formerly of Tesla and a co-founder of OpenAI, has shared his sophisticated, multi-layered approach to programming. Karpathy doesn't rely on a single AI tool. Instead, he orchestrates a four-stage toolchain, leveraging the unique strengths of different platforms to maximize efficiency and tackle complex coding challenges. This methodology highlights the current reality. AI programming tools are most effective when used in concert, with each filling specific roles. Karpathy's workflow begins with the Cursor editor, which handles approximately 75% of his automatic code completion needs. He emphasizes that providing precise code snippets or comments at the right juncture in the code is far more effective for conveying task requirements to an LLM than lengthy textual descriptions, reducing both effort and latency. However, he notes that Cursor's code completion sometimes requires frequent toggling on and off to function optimally. The second stage involves using large language models to modify specific code segments directly. This allows for targeted refinements and iterations on existing code, streamlining the development process. Karpathy selects a particular piece of code and prompts the AI to make desired alterations, integrating AI-driven changes seamlessly into his project. The third layer of his toolchain involves independent AI programming tools such as Claude Code and Codex. These are deployed for implementing larger functional modules or when dealing with programming domains unfamiliar to Karpathy. While these tools offer significant assistance, Karpathy points out their limitations. They often require substantial code cleaning, style adjustments, and can exhibit a lack of attention to code aesthetics. He finds them prone to generating redundant or overly defensive code, such as excessive try-catch blocks or convoluted nested-if-else statements, instead of more elegant solutions like list comprehensions or concise helper functions. He avoids YOLO mode to prevent the AI from generating unwanted, extraneous content, frequently interrupting the process with the ESC key. Despite these drawbacks, Karpathy acknowledges their indispensability for tasks like generating custom visualizations, small utility scripts, or debugging, where rapid, specialized code generation is beneficial, even if disposable. Karpathy's final line of defense, reserved for the most intractable problems, is GPT-5 Pro. He describes instances where he, Cursor, and Claude Code were stumped by a bug for extended periods. In such cases, feeding the complete code to GPT-5 Pro allowed it to analyze the code within minutes and pinpoint deeply hidden errors. He praises GPT-5 Pro's ability to access and synthesize information from obscure documents and academic papers, making it invaluable for resolving highly complex issues. He also uses GPT-5 Pro for optimizing abstract logic and conducting comprehensive literature reviews on specific technologies, though he notes the results can be mixed, requiring careful evaluation. Karpathy's insights reveal a developer ecosystem where code is abundant and disposable, shifting the focus from writing code to effectively guiding AI tools. He acknowledges the potential for anxiety in keeping pace with AI advancements, but finds inspiration in exploring these new possibilities. The community's response indicates a widespread adoption of similar multi-tool strategies, with users suggesting further refinements like AI agents for documentation management or structured prompts to guide AI outputs more precisely. This layered approach underscores the current state of AI programming, a collaborative effort where human expertise directs a suite of specialized AI tools to achieve unprecedented development efficiency. We've seen how AI is changing coding and infrastructure. Now, let's wrap up with a quick recap of all the groundbreaking news. Get ready for the lightning round. And that's a wrap on this week's AI news. We saw GPT-5 revolutionize coding with its Vibe capabilities, discovered that AI data centers are surprisingly water efficient, learned how to run powerful AI models locally with ease, and explored Andrej Karpathy's masterful AI programming toolkit. Don't forget to like this video, subscribe to ChatGPT Insights for more cutting-edge tech updates, and hit that notification bell so you never miss an episode. Follow us on all social platforms to stay connected. See you next time.